All right, we're continuing our saga of the law of exponents. So today we're just going to review what we've seen so far, and then we'll have a couple more sections for some additional properties that we haven't learned about just yet. So first of all, we talked about positive exponents, and that's what we're going to stay with is the positive exponents today. In the future, we're going to learn about how you can actually have negative exponents, and they're still pretty easy to deal with. But we talked about how exponents have a base. You have a number called the base, and then a little number to the upper right-hand corner called the exponent, which basically tells you how many times you're multiplying the base by itself. So in this case, 2 to the third is just 2 times 2 times 2. All right, and then we did a property called the product of powers property. To multiply powers with the same base, add the exponents. We also mentioned that if you have coefficients in front, like we have here, you got to multiply those together. So I'm going to kind of write this down by separating everything out that's alike and show you how it combines together. So we're going to do 4 times 2 for starters. Then we're going to look at the u's, and we're going to have u to the 3, and we have a 1 right there, so 3 plus 1 power. And then for our b's, we've got a 4 and a 2, and since we're multiplying them, we add the bases, or add the exponents, so 4 plus 2. So when I combine all of this together, I'm going to end up with v to the 6th power, u to the 4th power, and 4 times 2 is 8. So when I simplify this expression, I get 8 u to the 4th power, v to the 6th power. So again, 4 times 2, 8. 3 plus 1, 4. 4 plus 2, 6. And that's all there is to it. So on our next one, we've got 2 out here, another 2, and a 3 for our constants. Then next for our x values, we got x's in there. So if we look at the exponents on that, we've got a 2, we've got a 3, and we've got another 2. And since these are all being multiplied together, to multiply powers with the same base, we just add the exponents that go with that base. And then we have our y values, and they have exponents of 3 and 2 and another 2. So when we simplify it, y to the 3 plus 2 plus 2 is y to the 7th. X to the 2 plus 3 plus 2 would be x to the 7th. And 2 times 2 is 4, 3 times 4 is 12. So that would be that expression when we apply the product of powers property. And these things are not something that you haven't done before. You know how to multiply numbers. You know how to add numbers. So it's just a matter of what numbers do you multiply and which numbers do you add. All right, so let's do a couple more. So to multiply powers with the same base, you add the exponents. So let's do a few more. So in this case, we've got a 1 out in front of this expression. Remember when you don't have any numbers, you just put a 1 there. So we're going to have a 1 times 4 for our coefficients. Then we're going to have an a to the 1st power right there, plus that 3 that's on the next one over. And then for our b's, we have b to the 2nd power plus 4. And then 1 times 4 is 4. 1 plus 3 is 4, so we have a to the 4th power. And then 2 plus 4 is 6, so on our b we have an exponent of 6. So there you go. All right, on our next one, we've got a 2 and a 4 coefficient out here. So we're going to go 2 times 4. Like I suppose if you wanted to, well, that's good. 2 times 4. Now how about the x's? We've got x to the 4. And as we look over, there's no other x's, so we just have an x to the 4th power. That's pretty nice, isn't it? Then for our y values, we have an exponent of 2 and an exponent of 2. So that would be 2 plus 2. And let's go ahead and simplify. 2 plus 2 is 4. So for our y, we have an exponent of 4. For x, we have an exponent of 4. And then 2 times 4 is 8 for our coefficients. So 8x to the 4th, y to the 4th. So let's kind of go back up and look at this. 2 times 4 is 8. X to the 4th, that's all, the only one there is, so that's where that came from. And then y to the 2nd and the y to the 2nd, those two added together to give us 4. And that's where our y to the 4th came from. All right, then we talked about a rule called raising a power to a power. So in that case, there's some parentheses, you got some type of an exponential expression inside, and then another power on the outside. So to simplify this, the rule was when you raise a power to another power, you multiply the powers together. So in this case, we have a power of 1 on the 2 and a power of 1 on the x and a power of 4 on the y. So we need to multiply this 4 by each of these powers on the inside. So that's going to result in 2 to the 1 times 4, which is 4. X to the 1 times 4, which is 4. And y to the 4 times 4, which is 16. And then if you're asked to simplify it all the way out, that would include getting rid of the exponent on the coefficient. So 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16. So this first number, if you simplify it all the way, would be 16 x to the 4th, y to the 16th. And just watch what it asks for in whatever problem you're doing, whether it's Alex or a RICE test or something. Make sure you read what it's asking for and then follow suit. Okay, on this next one, we've got 3 to the 1st power, x to the 4th, and y to the 3rd. So we're going to multiply that 4 that's outside of the parentheses by each one. It's kind of like the distributive property, isn't it? But in this case, it's the raising a power to a power property. So 4 times that 1 would be 3 to the 4th. 4 times that 4 would be 16, so x to the 16th power. And 4 times that 3 would be 12. So y to the 12th power. And then if we multiply 3 times 3 times 3 times 3 4 times, 3 times 3 is 9, 3 times 9 is 27, 3 times 27 is 81. And then x to the 16th, y to the 12th. There we go. Now, don't be overthinking this. Just follow the rules we're giving you and come up with the number out front and the amount of exponents that's appropriate, and you've done your job. All right, let's keep that going. Raising a power to a power one more time. So 2 times that 1 is out there in front, so that would be 2 to the 2nd. 2 times that 3 on the x would be x to the 6th. And 2 times that 3 on the y would be y to the 6th. And then if you simplify 2 to the 2nd, that's just 2 times 2, which gives you 4x to the 6th, y to the 6th power. All right, keep it going. This time we don't have any number out front and any coefficient. We just have exponents. So we're going to just multiply that 2 by each of those exponents. 2 times that 3 is 6. So on our x, we got a 6 power, a little bigger. And then on our y, we got 2 times 2, which is 4. And there is the answer to that particular problem. Okay, then we moved on to the quotient of power rules. And so we said that you should subtract the smaller exponent from the bigger exponent, wherever it happens to be, and then see what you end up with. So let's look at how this works. So first of all, if you have a couple of coefficients there, you just treat that as a fraction and simplify it. Looks like that one's already simplified. Then as far as our x's are concerned, we have the same amount of x's on the top as we do the bottom, so they would cancel each other out. And on this one, we have no y's on top, but we do have y to the fourth on the bottom of this fraction, so we just leave that as is, and that would be that problem taken care of. On our next one, we have 3 over 2, so we'll have a couple more that aren't exactly the same there. Now, as far as our x's will cancel out in this case. And there's only a y to the fourth on the top. Nothing to subtract from it or it from. So there we go. 3 halves y to the fourth. So this kind of shows you the difference when we basically have the same problem, but just rearranged where the x's and the y's were to show you how that works. Let's do a couple more that'll be a little more descriptive. So 4 over 2, to simplify that would just equal 2. So then as far as our x's, you got x to the second over x to the second, so those will cancel each other out. And then on our y values, since the 2 on the bottom is smaller than the 3 on the top, we're going to minus that, which ends up canceling the bottom one out, making it a 1. And then 3 minus 2 is 1, so that just leaves us with y to the first power. Okay, on our next problem, we've got 2 over 2, which simplifies to be just 1. Then for our m's, we've got a smaller m exponent on the bottom than we do on the top, so we're going to subtract that smaller one from the bigger one, which actually cancels this one out because it's m to the 0, which is 1. So then we have 4 minus 3, which is 1, so we have m to the first power on top. And on the bottom, we have an n to the second power, and there's nothing to cancel it out with, so it just stays that way, and there's your answer to that one. So our assignment is going to be positive exponents review worksheet. And if you're doing this from home, you should be able to print that out, or otherwise you'll get it in class. Thank you very much.